Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University. School of Education, SOE. Postgraduate Certificate in Information and Assistive Technologies for the Instructors of Visually Impaired, PGCIATIVI. MVEI 012 Assistive and Adaptive Technologies. Block 1 Overview of Assistive and Adaptive Technologies. Unit 1. Assistive and Adaptive Technologies. Historical Perspective. 1.1 Introduction. Technology is a broad concept that deals with usage and knowledge of tools and crafts, and how it affects ability to control and adapt to environment. The human race's use of technology began with the conversion of natural resources into simple tools. Today technology is having its penetration in every aspect of a human's life. On one hand, where it has revolutionized and added values to the life of normal human being, it has been proved to be a boon for differently abled. It is promoting greater independence by enabling people to perform tasks that they were formerly unable to accomplish, or had great difficulty accomplishing, by providing enhancements to or changed methods of interaction. It has had particularly dramatic benefits for people who are blind or visually impaired. It has made information easily accessible to them, helping them in mobility and hence reinforced independence among them at workplace and home. Until only recently, the world of print information, newspapers, books, signs, menus was largely closed off to people with little or no sight. But the power of computers has now brought this world within reach for those unable to see. Assistive or adaptive technology, as it is called, has exploded many barriers to education and employment for visually impaired individuals and hence backing their rehabilitation in the society. Students with visual impairments can complete homework, do research, take tests, and read books along with their sighted classmates thanks to advances in technology. Adults with visual impairments can continue to work and pursue a tremendous range of careers in mainstream society because of the use of computers and other devices. 1.2 Objectives. After going through this unit, you will be able to know what is assistive and adaptive technology. Importance of assistive and adaptive technology. Reasons which promoted development, inception of assistive and adaptive technologies. Single quote. Development of traditional and modern assistive and adaptive technology. Pioneers in development of assistive and adaptive technologies, and legal provision SL law endorsing development, promotion of assistive and adaptive technologies. 1.3 Definitions of assistive and adaptive technologies. Assistive technology, is any item, piece of equipment, or product system, whether acquired commercially on the shelf, modified or customized, that is used to increase, maintain, or improve functional capabilities of individuals with disabilities. It can be a very complex and multifaceted field, yet in some cases be a relatively easy and creative problem-solving process. It can have numerous definitions, depending upon the population, the desired outcomes, the type of technology used, and the experience and orientation of the consumers and professionals involved. The terms assistive device and adaptive technology are frequently used as a single phrase when discussing the general topic. In reality, many people use them interchangeably. The evolving trend is to use the term assistive technology to encompass both types of devices, plus services associated with their use. One definition of assistive technology may be a system of no-tech, low-tech, and high-tech tools and strategies that match a person's needs, abilities, and tasks. It is a tool to assist in the accomplishment of tasks that would be difficult or impossible to complete without assistance using only the available resources in the available time. Assistive technology products can enable people with disabilities to accomplish daily living tasks, assist them in communication, education, work or recreation activities, in essence, help them achieve greater independence and enhance their quality of life. Assistive technology devices can help improve physical or mental functioning, overcome a disorder or impairment, help prevent the worsening of a condition, strengthen a physical or mental weakness, help improve a person's capacity to learn, or even replace a missing limb. It can help individuals increase their independence, build self-confidence and self-esteem, improve the quality of life, and break down barriers when providing the tools for possible employment and educational opportunities. The benefits of assistive technology transcend boundaries of age, disability, and/or health. Challenges. From young children to seniors, a person may face a range of possible physical and/or cognitive challenges. 1.4 Historical perspectives. As the medical facilities enhanced and the care of infections and disease improved, the chance of survival and life expectancy bettered for people with disabilities. Their major sources of their help were members of the clan, neighbors, or paid servants. At the same time as Industrial Revolution came in, more and more new techniques came in the market, touching every facet of human life and making it comfortable. The need was felt to design and develop assistive and adaptive technologies for persons with disabilities so that they may lead an independent life and rehabilitate in the society. Its initial pioneers included earnest engineers aiming to help their CWN kids, family members, relatives, and friends with disabilities. A number of factors advance assistive technology. Events like wars or the thalidomide disaster. Persons with disabilities becoming developers and decision makers. Development in technologies. Visions and ideas of user. Financial resources. Public awareness. Activity of lobbies. Personal commitment of persons in responsible positions. Many nations became more aware of the large numbers of persons with disabilities and the problems they face. They realized that promoting technologies for PWDs will not only lighten their burden by making the community self-sustainable but will also contribute to their economical, social, and cultural growth. The group includes those born with disabilities and those whose abilities diminish during their lifetime through disease, accident, war, or aging. The attention was drawn towards addressing accessibility problems faced by persons with disabilities in the workplace and community. In addition, the demographic trend toward a growing elderly population in some countries raised the prospect of a large number of consumers with decreasing abilities. The serious impact this on mass market products is beginning to be recognized by manufacturers. The development started with low-technology traditional assistive and adaptive devices and gradually embarked to more advanced, complex, high-tech devices. Many simple, advanced and complex devices developed for persons without disabilities were adopted for differently abled by incorporating add-ons or making some changes in design. The reverse is also true. Many devices developed targeting persons with disabilities proved to be important among masses. 1.4.1 Traditional assistive and adaptive devices. The evolution of it pioneered with low-tech and simple devices developed for kin and friends with blindness, visual impairment by innovative personalities. A number of users themselves also contributed into the development and resting extensively. Traditional low-cost assistive devices for the visually impaired can be broadly divided into the following categories. A. Educational devices. B. Mobility devices. C. Vocational devices. D. Daily living devices. A. Educational devices. Various traditional educational devices, many of which are used today, also can be further classified into the following broad categories. A. Braille duplicators and writers. Thermoforge machine, Inditherm, is an indigenous semi-automatic braille duplicating machine for taking out multiple copies of the braille matter on the Inditherm or braille on sheets from the master prepared on the braille paper. This machine operates on the principle of vacuum in high temperature. Similarly, vacuum forming machine is also available in standard sizes for taking out multiple copies of braille matter using PVC, HIP, acrylic and ABS sheets. The manufacturers of these machines are National Scientific Company, New Delhi, Asian Power Cyclops, Dehradun and IDEM Thermoformers, Mumbai. Braille writers is an upward writing machine for writing on one side of the paper, enabling the braille to be read as it is written. This machine can be compared to a normal typewriter with the major difference that it has fewer keys for paper setting and embossing. The braille embosses combinations of 6 dots in a braille cell. It is made of metal with an enamel finish, with plastic key tops and adjustable margin stops. The paper is roller-fed and line spacing is achieved by pressing a special key. The most popular Braille writers are Stensby Braille writers, Perkins Braillers, Taj Braillers, Worth Perkins Braille, Meenal Braille. Their manufacturers in India are Moksha Enterprises, Hyderabad, Worth Trust, Katpadi, Tamil Nadu, Meenal Engineering Limited, Vadodara, Gujarat and MP. Industrial Corporation, Indore. B. Writing devices. Braille frame and Braille slate. Interline Braille frame is used for writing. Standard character interline Braille. The frame comprises a wooden board, a metal guide, a reversible paper clamp and a stylus. The clamp fits at the top of the board and has a small swivel stud for locking and holding Braille paper. When one side of the paper has been brailled, the clamp with the paper still held is turned over as a unit. The binding margin is made automatically. Tailor. Postcard frame is used for writing small character Braille on one side of the paper. The corner pins are arranged in such a way that the Braille can be read without removing the paper from the frame. When the top section is lifted, the paper remains attached to it. Pocket Braille frame produces small character Braille on one side of the Braille paper. This is specially used for making small and occasional notes. Styli are produced with handles of various shapes to suit individual needs. The points of all styli are made of stainless steel and the handles are of polished hardwood or synthetic material. Pranya sketching device is an innovative sketching device developed by Mrs. Pranya Bhatt and Mr. Dilip Bhatt, father of a low vision child, Nikunj N. Volunteers of Blind People's Association. It enables a visually impaired child as well as a low vision child to create simple sketches and diagrams out of a thread. It is based on principle of using acrylic thread as writing ink and nylon fabric. Fastener strips as a writing slate. The child holds the pen as any other normal pen for a sighted person and makes contact of the thread over the slate surface. It can make different shapes like circles, rectangles, curved lines, letters, graphic symbols, maps etc. Bhatt couple also won National Award for Outstanding Technological Invention for this. Manufacturers of these devices are National Rehabilitation Engineering Institute, Blind People's Association, Ahmedabad, National Institute for the Visually Handicapped, Dehradun and Sparsh Products, Dehradun. C. Braille paper. The Braille paper comes in different standard sizes and thickness. Manufacturers: Titaghar Paper Mills Limited, Andhra Pradesh Paper Mills Limited, West Coast Paper Mills Limited, Rohtas Paper Mills Limited, Orient Paper Mills Limited. D. Mathematical devices. Taylor arithmetic frame is an aluminum frame divided into star-shaped holes with 8 angles, thus allowing the double-ended metal types to be placed in different positions according to a set system. This frame is suitable for teaching arithmetic to visually impaired persons. Arithmetic and Braille writing slate has an arithmetic frame on one side and a writing slate on the other with a reversible type clamp and a stylus. Abacus is a simple instrument for performing rapid arithmetical calculations. It consists of a frame holding vertically arranged rods on which beads slide up and down. The bead supporting the beads is marked with a raised dot at each rod position and a raised bar between every third rod. The bars serve to indicate the decimal point and other units of decimal measure. Opening parenthesis dot. Primary mathematics kit is a specially designed kit for the visually handicapped children to comprehend mathematical concepts. It contains a plastic box, slide strips, number boards, fractional strips, Braille clock, geometrical shapes, geometrical figure tray, magnetic board, geometrical devices etc. NIVH, Dehradun, is manufacturing it. Spur wheel is a serrated wheel revolving in a plaited metal handle. It is used for making continuous embossed lines on the reverse side of the paper. Compass set includes foot ruler, protractor and set square in nylon and a spur wheel. It enables visually impaired students to use the same techniques as his sighted counterpart. The foot ruler and set square have embossed markings for their convenience. The compass has a removable component fitted with a toothed wheel for drawing embossed dotted lines on the reverse of the Braille paper. Geometry mat is a sheet of rubber for use as a base in conjunction with the spur wheel and Braille paper for making geometrical drawings. Opisometer: a bell rings each time the disc moves a distance of 1 meter. useful for mapping and understanding mathematical problems in length and perimeter. Other mathematical devices are 3-in-1, arithmetic frame, writing frame and abacus, composite braille slate, abacus, arithmetic frame, rubber mat and wooden frame, graded abacus, fraction boards, counting device, 100, tens units board, arithmetic as well as algebraic types, geometric shapes and solid suppliers of educational devices are NREI, BPA, Ahmedabad, NIVH, Dehradun, Sparsh Products, Dehradun and ALIMCO. A. Geography devices. Sensory quill is equipment for obtaining a raised line format of any writing or drawing. The height and texture of the line can be altered. It is useful in learning handwriting skills, mathematics, science, drawing and spellings. Manufacturer is VR Vardhaman International, New Delhi. Maps and globes raised relief plastic maps. Vacuum-formed plastic maps, printed in strong colors with names in letterpress for the benefit of person with low vision. The main towns are shown by large dots in principal, rivers by depressions. Braille symbols denote the names of seas, main rivers and towns, a key to which is given in the guide. The boundaries on political maps are indicated by raised lines. In India, political and physical maps are available for Asia and India. The vacuum printed diagrams are also available for various body systems, anatomy, physiology, etc. from Bharat Educational Stores, Meerut and Krishna Models Manufacturing Company Limited, New Delhi. Relief globes, a plastic globe in textured relief. The land masses are shown in different colors. The principal towns are indicated by raised dots, rivers and lakes by depressions. Dotted lines indicate the tropics, Arctic, and Antarctic circles. The international date line and meridians. The names of oceans and the main land are shown in Braille. Braille diagram board. Metal sheet fixed on a board with closely formed holes, in which round HDDED pins are stuck to form maps and diagrams. Manufacture is NIVH, Dehradun, F. Science devices. Conductivity apparatus demonstrates the difference in the heat conductivity of copper and iron. It consists of a wooden stand with horizontal heating rods, three-dimensional raised relief plastic charts, rigid PVC sheet, printed and formed in multicolors. The following charts are available: Botany General, Botany Advance, Zoology, Vertebrate and Invertebrate, Human Physiology and Human Body Systems including Human Skeleton, and Human Reproduction includes male and female reproduction organs. Manufacturer is Bharat Graphics, Chandigarh. B. Mobility devices. Canes. The following types of canes are available. Cymbal canes, made of sections of light metal tubing, generally aluminum or its alloys, joined through the center by means of an elastic cord. The canes fold up conveniently for carrying in the pocket or handbag. When required for use, the top section is held and others automatically fall into position. Devised for portability and not intended to be used other than as a guide aid and an indication that the user is a visually impaired person. This cane is popularly known as a Braille folding stick. Guide canes, a stronger version of the cymbal cane and intended to be more of a mobility aid but not a means of support. The four sections, covered with ribbed plastic sleeving, are joined through the center by means of an elastic cord enclosed in nylon sleeving. It is fitted with an elastic loop handle and a standard nylon tip. Long canes, a wooden or aluminum stick of 85 to 90 centimeters with following models: rigid, 2-piece, 4-piece. The aluminum cane is generally sleeved with PVC material, having a rubber grip and a nylon tip with or without a crook. C. Vocational devices. Vocational devices to ensure the followings: A. User's ability to perform a definite technological operation. B. Employment of various means of mechanization with the aim of lightening jobs. C. Complete safety of a person's labor. D. Preservation of residual touch, sight and hearing. A. High quality of manufactured products. F. Increase in labor productivity. G. Self-reliability as regard the operations he is required to perform. Goniometer is an instrument to measure body angles and it is useful to physiotherapists. Attachment to lathe enables the visually impaired to operate the capstan as well as the central lathe. It is an attachment which can be mounted on the movement bar and can be fixed to enable the person to operate the machine to a desired length. A new device has also been developed which emits a sound signal when the tool carriage reaches a desired point. A movable switch is fitted on the movement bar and can be fixed as desired. Whenever the tool carriage touches the switch, the sound signal is emitted. Spot welding. It has been developed by using 5 kg A-type lamination cord, 1 bobbin, 25 and 16 SWG copper wires, 1 carbon rod, 1 combination plier, metal box and 1 line cord wire. As it has low voltage with high amperage current, it is safe for visually impaired persons to carry out the soldering of joints. Advantages: no risk of any electric shock to the operator. Low cost. Portable. No need for dry solder. It can, however, be used only for copper wire soldering. Continuity tester is a low voltage electric circuit for testing continuity of winding wires in case of motor winding or other such operations. The light signal is replaced by the sound signal for enabling the operators. Advantages: use of 1.5 volts DC current ensures safety of user, as it reflects difference between high to low resistance and current leakage. It is sensitive. Tone resistance can be altered and it emits audio output. A visually impaired person can use it conveniently. /. Usable in the field conditions. Compact, easy to carry and low cost. Braille micrometer. The Center for Biomedical Engineering, Indian Institute of Technology, New Delhi has developed a new attachment of the precision micrometer for the visually impaired. With the use of the attachment, conventional micrometer readily available in the market is adapted for the use of visually impaired persons. Other vocational devices. The American Foundation for the Blind, New York, is supplying a variety of tools and instruments for the visually impaired as listed below. These tools are yet not available in the country. Rotomatic rule, folding boxwood rule, Stanley saw guide, Stanley drill guide, light probe, metal and voltage detector, Stanley combination square, Stanley caliper rule, star at micrometer, O house port O gram talking scale, audible carpenter's level, daily living devices. Daily living devices can be further classified into 5 categories. A. Clocks and watches. Alarm clock, a standard alarm clock adapted for the use of the visually impaired. It has strengthened hands and an open plastic dial having the hour positions indicated by 2 raised dots at the 3, 6, 9, 12 positions and single dots at the remaining hours. Manufacturer, Hayes Limited, Mumbai. Travel alarm clock. This adapted clock as mentioned above is fitted into a case. The whole clock is packed into the case when folded. When opened, the case also serves as a stand for the clock. ALIMCO alarm clock has time setting knobs. Manufacturer, ALIMCO, Kanpur. Pocket watch, a hunter watch, the hinged cover of which opens when the winding knob is depressed. Ringer timer, a 1-hour ringer, in streamlined plastic case for timing any operation where an audible reminder is required. Each 5-minute period is indicated on the embossed setting dial by 2 dots and the first quarter hour is additionally marked to show the individual minutes. Risser watch has the appearance of an ordinary watch, with the front cover being fitted with a transparent center. The front can be lifted with a lever mechanism when the winding knob is depressed. Manufacturer, Hindustan Machine Tools Limited, Watch Marketing Division, 2611, Level Road, Bangalore 560,001. Talking time is an electronic watch as well as alarm clock fitted with an electronic device which announces the time whenever the knob is pressed. It is possible to set time, date, day and alarm etc. All the settings are audible in signals. It is thus possible for a visually impaired person to do the setting himself. The most popular brands are Sony and Sharp. In India, Sikkim Time Corporation Limited, SITCO. Sikkim has introduced talking wristwatch. B. Games and puzzles. Playing cards, superior quality standard playing cards with the reverse embossing in standard braille on the top left corner. Chess, a wooden board with the black squares raised and all the squares drilled in the center for the reception of the pegged chessman. Holes are provided at each end for pieces not in play. The pieces are of uniform height, the white having a point at the top to distinguish them from the black. Dominoes, made of plastic and having raised black dots on a white background, with black inset pieces on the reverse. These dominoes are ideal for players with low vision also. Brahma puzzle. The puzzle consists of 3 pegs on a wooden base and 8 discs of different diameter each with a hole in the center. The purpose is to transfer all the discs from the peg to another without allowing any disc to be placed over a smaller one. Audible ball, made of strong good quality rubber in which holes have been punched. Small metal balls are inserted for creating sound, enabling the ball to be located when in play. An ordinary good quality ball of plastic of 5 cm radius can be converted into an audible ball by drilling a hole, putting small size pebbles and then sealing the hole using the soldering rod. This ball can be used for playing cricket. Such a ball has been developed by the National Institute for the Visually Handicapped. Dehradun is the most appropriate. Draft board, a wooden board with sunken playing squares. The colors of the men are distinguished by size. Pieces of double thickness are used as kings. A variety of other imported games are also available from Royal National Institute for the Blind, London. In India, manufacturer are NIVH and Sparsh. C. Sports. Football, basketball and soccer ball. These are equipped with a small electronic beeper which is battery powered and emits a compact sound. These devices can be imported through VR Vardhans International, Delhi. Swimming is also emerging to be a popular sport among visually impaired persons. The normal swimming pool with sound indicators on the sides can be used for training them in swimming. Athletics, the normal track with some precautions and safety measures can be used for training the visually impaired in race, shot put, javelin throw, bag walk. Musical chair, hit the target etc. Table tennis has become a popular indoor game for the visually impaired in many Southeast countries. The normal table tennis table with some modifications in the net and the sides can be used for TLIE purpose. D. Kitchen equipments. Equipment adapted for the visually impaired egg poaching ring, an adaptation of standard egg ring to enable visually impaired persons to fry or poach eggs, and to serve them easily. It has a handle, vertically attached to the egg ring. Measuring jug, a heat-proof clear glass jug of standard capacity with raised markings inside to indicate the specific volume. With the use of fingers, a visually impaired person can measure the volume. Bread cutting box, an adjustable slide is fitted to gauge thickness of the slice. It enables visually impaired persons to cut the loaf of bread into even slices using a standard bread knife. Liquid level indicator, a simple electronic device powered by a battery, enables a visually impaired person to ascertain the level of liquid being poured into a cup. It emits a sound signal when a particular level is reached. Self-adhesive labels. These plastic labels can be embossed with braille in, used for labeling a wide variety of articles. These equipments are still not available in India. These have to be imported from the Royal National Institute for the Blind, London. A. Personal devices. Sound beacon. This pocket-size electronic device emits a sound which can be varied from a loud continuous whistle down to low intermittent beeps at various rates. It is generally used as a homing device. Notes. It consists of a rectangular base and tabs made of high-density polythene hinged together. It differentiates Indian currency notes of different denominations. It considers length and breadth of a currency note for its differentiation. Available from NAB Louis Braille Memorial Research Center. Magnets, round, square and U-shaped magnets for picking up pins, small nails, and other iron or steel objects. Signature guide, a template to guide the visually impaired persons in placing signature in proper position on letters, checks etc. Address templates, made of cardboard with 4 raised lines to guide a visually impaired person to write his address on inland letters and envelopes. Light probe, full function light detector, may be adjusted for desired sensitivity to light. Location finder, find your house, apartment, or office easily with portable Lightweight location finder. A siren, attached outside location, will sound on pressing transmitter attached to a keychain. Dot. Other personal devices. The American Foundation for the Blind and MAXI devices are supplying a variety of personal devices for the visually impaired persons as listed below. These are so far not available in India. Thermo Voice announces temperature, talking blood pressure and pulse monitoring kit. Becton Dickinson Magni Guide for accepting barrel of insulin syringe. Insulin needle guide, talking blood glucose monitoring kit. Big print address book, talking wallet. Locklet saucepan, weight talker, key finder, clothing identifiers, tactile braille signs. IE's eye drop guide, medicine spoon. 1.4.2 Modern Assistive and Adaptive Technologies. Modern assistive and adaptive technology basically includes assistive technology programs that run on off-the-shelf computers can speak the text on the screen or magnify the text in a word processor, web browser, email program or other application. Standalone products designed specifically for people who are blind or visually impaired, including personal digital assistants, PDAs, and electronic book players provide portable access to books, phone numbers, appointment calendars, and more. Optical character recognition systems scan printed material and speak text. Braille embossers turn text files into hard copy braille etc. History of modern assistive technologies for persons with visual impairment and blindness starts from 1970s. In 1970 Telesensory Systems, Inc. was founded, which did exceptional work to develop, manufacture, and market products for blind people. At the same time Opticon, a portable electronic print reading device, was developed at Stanford University. In 1975 Kurzweil Computer Products was founded by renowned inventor Raymond Kurzweil in Massachusetts. At the same time Duxbury Systems, founded in the town of Duxbury, Ma, began work on a Braille translator product. And in a year its first installation took place at the Canadian National Institute for the Blind. Concurrently first talking calculator with 24-word vocabulary was produced by Telesensory Systems. In 1978 Kurzweil introduced its reading machine able to convert books and other printed material into synthetic speech for print-disabled persons. At the end of the decade Telesensory Systems, Inc. introduced the Versa Braille, a computer with a Braille keyboard and a Braille display. In 1980 Triformation Systems, Inc., Florida, developed the plate embossing device, PUD. It reads computer files and stamps Braille dots into heavy zinc. Previously, the plates from which Braille books were pressed were prepared by hand. Maryland Computer Services, formed in 1976, introduced the Cranmer modified Perkins Braille, the first low-cost Braille printer in 1983. At the same time, Versa News, a quarterly magazine on Versa Braille and other Braille technology, began publication and Info, the first talking database program with voice synthesizer, released by Computer Aids of Fort Wayne, Indiana. Concurrently, Raised. Computing also announced the Super Cranmer graphics package. The program took high-resolution images on the computer screen and transferred them to the Cranmer modified Perkins Braille, which made creating tactile charts, maps, and diagrams easier. In the same decade of 1980s TACTIC, a magazine offering consumer-oriented overview of products that work for blind computer users was introduced. Digital Equipment Corp. Introduced DEC Talk, a high-performance voice synthesizer with 7 built-in voices. The decade is also a spectator of various DOS screen readers. Introduction. Raised. Computing came up with Braille Edit, a word processor and two-way Braille translation program using voice, print and Braille, and subsequently released its enhanced versions, i.e. BET, BEX and Hot Dots. In the middle of the decade, the American Foundation for the Blind's National Technology Center, established to help blind and visually impaired people participate fully in the computer age at UB's New York headquarters. Its focus was on high-technology research and development, evaluation, and database services to enable blind people to work with and have access to the same information as their sighted peers on the job, at school, and at leisure. In 1987, Ted Henter founded Henter Joyce, Inc. in St. Petersburg, Florida. The company's main products would include the DOS screen reader JAWS, Job, Access with Speech, and JAWS for Windows. Bill Joyce, a blind entrepreneur from Chicago, financed the company. JAWS is now one of the most famous screen readers in the world. At the end of the decade, Telesensory Systems, Inc. acquired Visual Tech, forming the largest company in the world devoted exclusively to the manufacture of high-technology assistive devices for people who are blind or visually impaired. At the same time, it introduced the Navigator, a 40-cell Braille display, subsequently first screen reader for the Apple Macintosh computer. Using its built-in synthesizer, Macintalk was introduced by Berkeley Systems. In 1990, Telesensory Systems, Inc. introduced Oscar, a DOS-based optical character recognition system. In a short time, it also introduced BrailleMate, a Braille note-taker with speech output, Braille keyboard and 1-cell Braille display, and Power Braille, a 40-cell Braille display. There were also 65 and 80-cell models. Shortly, Telesensory came up with Aladdin Classic CCTV and Screen Power, its DOS screen reader. In 1992, Xerox Imaging Systems Inc. released the Reading Edge, a standalone OCR product including a DEC talk synthesizer. In the middle of 90s, Microsoft came up with Windows 95 with its visual interface including a customizable mouse pointer, high-contrast color schemes, scroll bars and window menus. This triggered the market of computer screen readers, and a number of developers released their readers. Telesensory introduced Screen Power for Windows, a screen reader with speech and Braille access to Windows applications. Concurrently, another Windows-based screen reader, Window Eyes, came up in the market from GW Micro. Window Eyes is now one of the widely used readers. Dolphin Computer Access released HAL for Windows 95 version 1, a screen reader using a unique screen access engine to provide fully automatic access to Windows 95 applications. On the other side, as Internet blossomed and brought a revolution in communication technology, making world virtually a small abode, the companies in the field and users felt the need of making Internet accessible. Taking initial steps towards this, a New Jersey-based consortium of business, education, and accessibility experts announced the availability of a new product, PW WebSpeak, a self-voicing Internet browser. Subsequently, the World Wide Web Consortium, W3C, announced the launch of the Web Accessibility Initiative, WAI, to promote and achieve web functionality for people with disabilities. Endorsed by the White House and W3C members, the WAI involved the establishment of an International Program Office, IPO, responsible for developing software protocols and technologies, creating guidelines for the use of technologies, educating the industry, and conducting research and development. As we move towards a highly connected world, it is critical that the web be usable by anyone, regardless of individual capabilities and disabilities, said Tim Berners-Lee, director of the W3C and inventor of the World Wide Web. The W3C is committed to removing accessibility barriers for all people with disabilities, including the deaf, blind, physically challenged, and cognitive or visually impaired. In J996, talking book libraries from all around the globe came together to form the DAISY Consortium. This consortium managed the transformation from analog to digital technology to provide books in accessible format to persons with vision impairment. The consortium developed standards to create and organize data in a way which is usable anywhere in the world and is producible in all accessible formats. In 1997, Windows 95 Explained, a guide for blind and visually impaired users, by Sarah Morley, was published by the Royal National Institute for the Blind. It described fundamental Windows 95 concepts from a non-visual perspective, and provided a listing of Windows keyboard commands together with a comprehensive glossary. The book was available in print, Braille, on ASCII disc and cassette with accompanying tactile and large print diagrams. Another milestone was achieved in 1999, when first talking ATM was installed in United States. At the same time, the National Library Service for the Blind And physically handicapped, NLS, launched Web Braille, a new system for distributing Braille books via the internet. Braille books made available for download are online use by eligible individuals, libraries, and schools with Braille embossers, refreshable Braille displays, and other Braille devices. The beginning of the present century was full of activities in the field. First, news of merging of Hunter Joyce with Blasey Engineering to form Freedom Scientific Inc., a new company offering assistive technology products for people with sensory impairments and learning disabilities hit the market. Within 2 months, the new company acquired the business operations and product lines of Arkenstone, Inc., including its Open Book, Vera, and Win product lines, as well as its name, intellectual property, and business assets. Another major event in the year was release of Windows 4.0 by GW Micro. New features included were Braille display support for Windows Millennium, and enhanced support for Internet Explorer 5, 5.01, and 5.5. The year also witnessed the installation of first 15 talking automated teller machines, ATM, by the Bank of America in California. In start of 2001, Freedom Scientific released Connect Out Loud, a lower-cost screen reader which provided speech and Braille access to Internet Explorer, Outlook, and simple word processing. Subsequently, another screen reader magnifier software product, Supernova, from Dolphin Computers came into the market. Supernova works with Windows XP and offers magnification, speech, and Braille access. In last quarter of the year, Freedom Scientific Inc. posted a free public beta of JAWS for Windows version 4.01 that was compatible with the new Windows XP operating system equals just 2 weeks following Microsoft's release. In February 2002, Bookshare.org was launched by Benetech. The website is an internet library for people who are blind or visually impaired to legally store and share scanned books. Visionary Laptop, a screenless laptop computer with an integrated text-to-speech application, was introduced by Beyond Sight in the same year. In the year 2002, DAISY Consortium published version 2.02 of DAISY standards. With these standards, the concept of DAISY books shifted from just being a talking book to a book with audio and text. This also paved the way for development of the concept of creation of single-source document and producing Braille, talking or large print books from this single-source document. Telesensory Corp. introduced Genie Pro, a computer-compatible video magnifier designed for use with most computer monitors or televisions in first quarter of year 2003. The features include 5.5x 50x magnification, split screen, 24 color combinations, and shadow mask, which is designed to assist in text tracking and glare reduction. In March 2004, American Printing House for the Blind introduced the BookPort digital talking book player. This palm-sized device can hold hundreds of audio files, allowing a person to listen to books or magazines, jump around easily within text, set bookmarks, and enjoy other features that facilitate reading. The BookPort can read DAISY, text, and MP3 files. DAISY denotes the Digital Accessible Information System. DAISY standards defines how we can produce books in talking, Braille, large print and text format. In the year 2005, version 3 of DAISY standards were released and these were adopted as NISO standards. Several authoring and playback tools were released by many companies to produce and playback the DAISY digital books. As the mobile phone technology grew, the handsets became small and lighter, and service came at an economical price. Its user base increased many folds in a small span of time and is continuously growing. The need of making this significant communication technology accessible was felt in the community. The first full-fledged screen reader for cellular phones, Mobile Speak, was released by Code Factory in April 2004. KNFB Technology Inc., a joint venture of Kurzweil and National Federation for the Blind, USA, also produce reading software especially designed for and paired with the Nokia mobile phones.
1.5 Pioneers of Assistive and Adaptive Technologies. 1. Jim Bliss. Jim Bliss along with John Linville developed the Opticon and founded Telesensory Systems in 1970. Bliss also focused on easy-to-use PCs for older people who are visually impaired and remained chairman and CEO of Telesensory up to late 1980s. 2. Larry Israel and Jim Halliday. Larry Israel and Jim Halliday, both live in Darraville, California, were integral parts of the history of telesensory systems. Israel is a pilot and an excellent business investor, and Halliday is an accomplished piano player. Israel founded Visual Tech, closed circuit televisions, in 1971 to market Sam Janensky's creation, closed circuit televisions, and to compete against Apollo lasers. Telesensory purchased Apollo lasers in the early 1980s and 3 years later bought Visual Tech, then called V-Tech, from him. 5 years later, after Bliss had been forcibly replaced as chairman and CEO by Jim Morrell, Israel took over from Morrell and became chairman and CEO of Telesensory. Resigning from Telesensory, in 1999, Israel returned to the board in the early 2000s. He was on the board when Telesensory went out of business in 2005. Halliday, Telesensory, Humanware, Pulse Data Humanware, and now the Humanware Group, began his professional life as a Mormon missionary. Got into media production in the California Community College system, and found his way from there to Telesensory, where he headed its sales force. In 1987, he left Telesensory to pursue a new venture, one that would emphasize the human factors aspect of assistive technology. It was then that he received a call from Russell Smith, who was managing the buyout from the Wormald International Group that led to the creation of Pulse Data in 1988. Smith hired Halliday to develop Pulse Data's American affiliate, the company called Humanware. After nearly 35 years working with people with disabilities, Jim Halliday officially retired in March 2008. Halliday is still involved with Humanware on a consulting basis, driving the launch of the new deaf-blind communicator and representing Humanware as president of the Assistive Technology Industry Association Board and on the board of the American Center on Blindness and Visual Impairment. He will remain active as a speaker at industry conferences, as a resource to Humanware's product development, and as an ambassador for assistive technology. Single quote. 3. Bob Keenan. Bob Keenan was a sales representative for Telesensory and Humanware, and worked as an assistive technology specialist for Lighthouse International. 4. Russell Smith. Russell Smith was the head of Pulse Data International, now part of the Humanware Group. He remained in the blindness assistive technology business after he earned his Ph.D. On August 7, 2005, Smith and his wife died in a plane crash. He was 61. The legacy he left includes one of the most prolific and enduring assistive technology companies in history. During his tenure, Pulse Data's blind-friendly, portable note-takers, driven by the specially designed Keysoft suite of programs, revolutionize the market of products for people who are blind. Smith's philosophy of creating technology for blind people that operates according to their unique needs captured the loyalty of many consumers. Smith's most recent gifts to consumers who are blind or have low vision include the BrailleNote PK, the Brailliant Braille display, and the MyReader digitally based electronic magnification system. 5. Leslie Kay. Kay acquired his knowledge of specialized sonar in the British Royal Navy after World War I, observing blind children enjoying themselves in a community swimming pool in England, and studying the use of sonar by bats. Kay, whose degree is in engineering, decided to combine concepts of airborne sonar with human learning and to develop devices for people who are blind. By the mid-1960s, he had developed the sonic torch, The Sonic Guide, a head-borne device, and the MOIT sensor are offshoots of the original sonic torch. These devices are required a great deal of training to interpret accurately the audible signals generated from sonar that were designed to bounce off objects in the environment and return to receivers on the device, were not well received by the market. Today's KSONAR device mounts on a cane, is easier to learn, and is somewhat less expensive. Pulse Data Market K's sonar-based devices. 6. Harvey Lauer, an industry advocate and early leader, worked for many years at the Heinz Veterans Administration Medical Center, birthplace of the now traditional long cane technique. Over the years, he has, among other things, been advisor to the Opticon team at Telesensory and David Holliday at Raised Computing. 7. David Ho Uade and his wife, Dr. Karin Navy, David Holliday and his wife, Dr. Karin Navy, whose house is demarcated by a large sign that says Braille Planet, a remnant of the company that Holliday sold to Joe Sullivan and Duxbury Systems just before he and Navy joined the Duxbury team. In 1981, inspired by his wife's need for Braille translation of mathematical materials so she could more efficiently teach university classes, Holliday decided to apply his considerable engineering and programming skills to creating Raised Computing and the Braille Edit product, speech and Braille translation software that ran on Apple computers. They developed Braille Edit and Megadots. 8. Bill Jerry and Tom Fowle, Jerry's father, a blind master piano tuner, taught his son the value of mechanical skills and the love of good music. Both blind engineers, Jerry and Fowle, have a long-standing reputation for inventing specialty devices for people who are blind with unusual needs, such as wheelchair navigation and the use of complex scientific instruments. They provided interesting insights into how they believe people who are blind should be regarded by the general public and how assistive technology for people who are blind should coincide with the way they actually perceive the world. 9. Jerry Kunz. Kunz is an old-time industry observer who has worked as a rehabilitation counselor, developer of assistive technology programs, and sales representative and, lately, an instructor in assistive technology for students who are blind at the California School for the Blind. In the late 1970s, he spent time with Steve Jobs and Steve Wozniak in their garage while they invented the Apple computer. He has known most of the players in the business since the 1970s and has helped several assistive technology companies develop their philosophies and sales approaches. 10. Larry Scadden. Scadden is another longtime industry leader and observer who provided fascinating historical perspectives on the industry. His years at the National Science Foundation permitted him to fund such projects as the University of Washington's Do It, Disabilities Opportunities and Internetworking in Technology, and several initiatives to eliminate barriers to careers in the sciences for people with disabilities, access to laboratories and laboratory equipment, accessibility of instructional material, and attitudes of teachers. 11. Sam Janensky. Sam Janensky, known as father of the closed circuit television, TV, is a mathematician who, as a boy, used a self-designed binocular device to maximize the effectiveness of his poor vision. In the 1960s, Janensky worked for the RAND Corporation on top-secret projects for the Navy and Air Force. While there, he and his colleagues developed the CCTV system that was originally marketed by Apollo Lasers and Visual Tech. Eventually, the product lines of both these companies were absorbed by Telesensory and imitated and improved upon by many other companies over the years. 12. Dean Blasey and Ted Henter, at his first company, Maryland Computer Services, Blazy developed Total Talk, the Furzer talking computer terminal. One of his early customers and advocates was a newly blind computer programmer, Ted Henter. At Blazy Engineering, Blazy and his team developed the Braille and Speak and Braille Lite series of portable note-takers, the Braille Blazer Embosser, and more. The secret to Blazy's success in the portable Braille device industry was his willingness constantly to survey and react to the needs of consumers who are blind. Henter Joyce, did his basic talking computer training under Blazy, and, when the PC came into its own, set out with a silent investor, Bill Joyce, to develop JAWS, job access with speech, screen reading software for DOS and, most famously, Windows. Raised in the Panama Canal Zone, and a championship motorcycle racer, Henter worked as an engineer until 1978 when he lost his vision in a car accident in the United Kingdom while preparing for the World Motorcycle Racing Championships. His newest company, Henter Math, develops and markets the Virtual Pencil, a PC-based math problem-solving tool. Henter is currently on the board of Freedom Scientific, to which he sold Henter Joyce in 2013. Jim Fruchterman. Jim formed Arkenstone in 1989 as a not-for-profit organization within one of his for-profit businesses, so he could charge lower prices and compete with ad hoc systems and Kurzweil. Arkenstone was best known for its open-book OCR product. After Fruchterman sold Arkenstone blindness products to Freedom Scientific in 2000, Jim formed Benetech, which means good technology, which created the innovative Bookshare project. Bookshare gathers books that have been scanned by people who are blind and makes them available for download on a subscription basis. 14. Ray Kurzweil, Ray Kurzweil, Wellesley Hills, Massachusetts, used his knowledge of artificial intelligence to develop the scanning and OCR technologies that were necessary for his first reading machine. When PC and speech synthesis technology evolved to the point where his products could become part of the desktop, he formed Kurzweil Educational Systems. KES 1.6 Indigenous Assistive and Adaptive Technology. In India, most of the assistive technology has been adopted from developed countries either in the same form or modified as per requirement. However, some work has been done by different institutes like TITS, government promoted bodies, organization like Media Lab Asia, CDAC, Webel Mediatronics Limited, NIVH, ALIMCO, and NGOs like NAB, BPA, etc. Some of these devices and technology include screen reading software, SAFA, modified Perkins, Braillers, Braille shorthand machines, Braille keyboards, tactile readers, different telescopes and magnifiers, accessible web browser, Shruti Drishti, speech synthesizer in vernacular languages, different educational, daily living, and leisure aids, etc. The stress in India is more on to develop technologies which are already available in international market in local languages and to make them available at low cost. 1.7 Laws and Assistive and Adaptive Technology. As the people and government became aware and attention was drawn, various laws and legal recommendations also formalized for the assistive and adaptive technologies. For EGPWD Act 1995 states, the appropriate governments shall initiate or cause to be initiated research by official and non-governmental agencies for the purpose of designing and developing new assistive devices, teaching aids, special teaching materials, or such other items as are necessary to give a child with disability equal opportunities in education. The Act also says that the appropriate governments and local authorities shall promote and sponsor research, inter alia, in the area of development of assistive devices including their psychosocial aspects. The principle of equal opportunities had great penetration in society all over the world and was also gradually endorsed by United Nations. Therefore, UN released Conventions on the Rights of Persons with Disabilities at the end of 2006. The conventions also states following points regarding assistive technology and information and communication technology. 1. Communication includes languages, display of text, braille, tactile communication, large print, accessible multimedia as well as written, audio, plain language, human reader and augmentative and alternative modes, means and formats of communication, including accessible information and communication technology, to undertake or promote research, arid development of, and to promote the availability and use of new technologies, including information and communications technologies, mobility aids, devices and assistive technologies, suitable for persons with disabilities, giving priority to technologies at an affordable cost. 2. 3. To provide accessible information to persons with disabilities about mobility aids, devices and assistive technologies, including new technologies, as well as other forms of assistance, support services and facilities, to enable persons with disabilities to live independently and participate fully in all aspects of life. States parties shall take appropriate measures to ensure to persons with disabilities access, on an equal basis with others, to the physical environment, to transportation, to information and communications, including information and communications technologies and systems, and to other facilities and services open or provided to the public, both in urban and in rural areas. These measures, which shall include the identification and elimination of obstacles and barriers to accessibility, shall apply to, inter alia. 4. 5. To promote access for persons with disabilities to new information and communications technologies and systems, including the Internet. 6. To promote the design, development, production and distribution of accessible information and communications technologies and systems at an early stage, so that these technologies and systems become accessible at minimum cost. 7. Facilitating access by persons with disabilities to quality mobility aids, devices, assistive technologies and forms of live assistance and intermediaries, including by making them available at affordable cost. Providing information intended for the general public to persons with disabilities in accessible formats and technologies appropriate to different kinds of disabilities in a timely manner and without additional cost. Accepting and facilitating the use of sign languages, braille, augmentative, and alternative communication, and all other accessible means, modes and formats of communication of their choice by persons with disabilities in official interactions. 8. 9. 10. Encouraging the mass media, including providers of information through the Internet, to make their services accessible to persons with disabilities. India ratified the UN Conventions on Rights of PWDs in 2007. India is also running a scheme of assistance to PWDs for purchase, fitting of aids, appliances, ADIP. The main objective of the scheme is to assist the needy persons in procuring durable, sophisticated and scientifically manufactured modem, standard aids and appliances that can promote their physical, social and psychological rehabilitation, by reducing the effects of disabilities and enhance their economic potential. The aids and appliances supplied under the scheme must be ISI marked. 1.8 Unit Summary. In this unit we learned what are assistive and adaptive technologies, what promoted, incited their development and manufacturing, and how assistive and adaptive technologies have effect in the life of persons with disabilities. We also came to know traditional technologies developed for persons with blindness and visual impairment. We went through chronological order of development of modem Technologies starting from year 1970s and how government authorities came up with legal instruments to support development, dispersion of technologies to needy. Thank you for watching. We will see you in the next video, with next chapter.